Alright guys, in this video we're going to cover pages 324 and 325, still under our lesson 4 of how do scientists draw conclusions. And so the first thing that we're going to talk about is keeping records. So we talked in the previous video about how important it is to record procedures. The next step is to keep records. So by keeping detailed and accurate records of observations, scientists are able to share their information with others. The more scientists repeat an experiment and get the same results, the more they can rely on the data. Conclusions based on reliable data are more likely to continue to be useful in the future. For example, think of the diver on the previous page. If the records of the dive are accurate, scientists can look for more or different information on future dives. Scientists continue to repeat an experiment until they are sure of the results. If scientists repeat an experiment and get different results, they look for reasons why the experiment was different. Good records and procedures can be helpful in finding those reasons. The next important step is to organize your data. And remember, data means information. It's the information you get from your experiment. So scientists keep accurate records of their experiments. Often they organize their data in a table. The table below contains important information about the bouncing ball experiment. The title explains what was tested. And here's your title right here. Bounce heights of a table tennis ball. The table names the materials used and gives the test results. So here's where the materials are. They used carpet, wood, and rubber. That's the rubber mat. The table also shows that the experiment was done 3 times. Here's trial 1, trial 2, and trial 3, and each of those shows the bounce height. And in this case, it's measured in centimeters, which is just a little bit different than inches. All right, so number 2. Text features. Now we know that text features are photos, tables, graphs, anything that's on a page that gives us visual information. These headings, subheadings, are also part of text features. So what information does the table give you? Because the table is a text feature, and we find text feature usually in informational text like our science textbook. What information does the table give you? Well, it gives you, usually this can be found in the title, it gives you the bounce heights of the table tennis ball. And we're going to write this in a complete sentence. It gives you, or it gives the bounce height heights of the table tennis ball. Period. It's always a good habit to get into the habit of writing things in complete sentences. That way you keep practicing starting your sentences with a capital letter and ending with an end mark, okay? Number 3, conclude. Make a conclusion based on the data. Which surface caused the ball to bounce the highest? Okay, so we're going to look across here in our numbers. These are the centimeters, 10 centimeters, 12 centimeters, 9 centimeters. Those are all on carpet. The wood produced, when the ball was bounced onto wood, it produced bounce heights of 70, 68, and 65 centimeters. And on the rubber mat, it bounced 15, 20, and 17 centimeters. So which surface caused the ball to bounce the highest? Well, obviously, it would be wood because these numbers are much larger than the other. And so our answer would be the ball bounced the highest on the wood surface. Okay, moving on to page 325. The next important part of drawing conclusions for scientists is presenting data. And so there are many different formats for organizing and arranging your data. The table on the previous page is one format. Charts and graphs can also be helpful because they show information in a way that is easy to understand. However you format your data, it should be clearly labeled. Okay, so on page 324, we saw a table with numbers and all of the information arranged in a table. And so the same information is presented here in a bar graph. And so a bar graph is a kind of way that you can present your data. A bar graph uses rectangular bars. Notice these are all in the shape of triangles. Rectangles. It uses rectangular bars to compare data. The bars may be vertical, this was up and down, or they may be horizontal, okay? The bars often have different colors or shading for each variable. And so if you'll notice here, the greenish color looks like, the greenish color represents carpet. The orange represents wood, and the blue represents the rubber mat. And so over here, we have a question about our conclusion. In the bar graph shown here, what would happen if the color key was missing? If we didn't have that color key to tell us which color represented which surface, we wouldn't be able to tell which bar stands for which piece of information. So we can say you would not be able to tell which bar represents which surface. And the bar graph is actually even easier to read or easier to immediately come up with an answer. If you notice, bounce height is shown this way, and so we know that the orange is wood. So the first thing we notice is, okay, obviously whatever the orange rectangle, whatever the orange bar represents is the one that bounced the highest. And so we would look across here and see, okay, the orange stands for wood, so it's very easy to notice that the wood surface is the one that bounced the highest. Okay, so a line graph is the last one that's going to talk about on page 325. And line graphs connect points of data on a graph with straight lines. Line graphs are often used to show patterns of data over time. For example, a line graph could show the amount of rainfall a place gets over 2 weeks, and a graph may use different colored lines to compare different data. So you could actually see like maybe a red line that shows something different in the same line graph. And so this particular line graph is giving us the information on the daily precipitation in Dallas-Fort Worth, at the Dallas-Fort Worth Airport during the month of October 2009. And here is the precipitation in inches. Now obviously precipitation is going to include rain, snow, sleet, all of that stuff for October. And so you see every day it was measured, and then they connected just different points to show you that if you take a look here, the highest point, or the most rainfall or precipitation that the Dallas-Fort Worth Airport had in October of 2009 would have been on the 9th of October. And so express data, we would work with the partner to write a 1 to 2 sentence explanation of the data in the line graph. And so I'm just going to give you a possible answer that you can write down. And we can see that one day on the 9th, it rained a lot, okay? And then on the other days, they received little or no rain. So our possible answer down here is going to be it rained a lot on one day. During this 2-week period. And I did say the month of October. It is in the month of October, but you'll notice it only is from the 1st of October to the 14th. So it's 14 days is 2 weeks. Other days received little or no rain. And we can assume that this precipitation is rain because it would likely not be snowing in Texas in October. So we are making an assumption or an inference there that it is rain that is recorded by that is indicated by precipitation. Okay, good job, and I will see you guys in the next video.